guys, welcome to my channel subhassir'sclasses. Today we are going to study differential equations meant for 12th class 12 of any board, maybe NCERT, maybe CBSE, maybe state board or maybe ICSE. This part of mathematics is the most advanced level of mathematics. For this you must be okay with your calculus knowledge, your trigonometric knowledge, and so let us go in details what this chapter means. In differential calculus, this part, the differential equation, is a bit algebraic. There is less geometry in it and more algebra in it. So what we have to study in this whole course should be divided into three parts. The part 1 should mean about the differential equations, what are differential equations, how we find the degree and order of a differential equation, and how to form a differential equation, what is the elimination method, and then what is the solution of a differential equation. Are there two different types of solutions? What is a particular solution and what is a general solution? Then we shall have some simple solutions solving differential equations where there is a separation of variable method and when there is a second derivative, and then we shall end this part of the differential equation, and in the second part we shall go for linear differential equations, which involves two different processes, and there is the use of IE, the integrating factor, and when we find the integrating factor we multiply it both the sides of the equation and solve it. That is a long method, and although easy, you have to go through it, and it should be in the second part. And in the third part of the chapter, differential equations, we shall go for homogeneous equations. There are two different kinds. The simpler types are of the pattern a1x plus b1 by a2x plus b2, or a1x1 plus b1x1 by a2x2 plus b2y2. So in the second type, the complex type, where we have to convert them into homogeneous form, we find the functions of the type f of xy upon g of xy plus k1 plus k2. So we convert them into the simpler homogeneous form and then solve, and with this the total chapter ends. So let us first go for the part 1, where we shall study what is differential equation, which equation should be called a differential equation and which is not. Next we shall go for degree and order. Next we shall go for formation of differential equation and the methods. So let us start. What is a differential equation? What is a differential? A differential is something that appears like this. Say x dx minus y dx is equal to 0. This is called a differential equation. Why? Because there are two differentials, differential in y dy and differential in x dx. So if differentials are involved in any equation that looks like an algebraic equation, then it is called a differential equation. Then if x dy minus y dx happens to be a differential equation, then what is its degree, what is its order, and what are degree and order of a differential equation? A differential equation, or in short it is DE, a differential equation has a degree and an order. When you have x d square y by dx square plus 2 dy by dx plus 5 is equal to 0, then this must be a differential equation. But in this we find here, x d square y by dx square plus 2 dy by dx plus 5 is equal to 0. Here we find this is a second order derivative, means the y has been differentiated twice successively. So there are two successive differentiations here, and only a single differentiation here and no differentiation. So the largest successive differentiations here is 2 and here it is 1. That's why order of this equation will be 2. So second order. Why? Because it is a second order derivative or second successive differentiation has taken place. So in any equation in which the maximum number of successive differentiations is 2, it is a second order equation. And if this term will be omitted, it will be a first order, because this is only a single dy by dx. Similarly, let us go for more orders. d cube y by dx cube plus 2 d square y by dx square minus 4 dy by dx plus 11 is equal to 0. We can easily find out that the number of successive differentiations here is 1, it is 2, it is 3 here. So maximum number of successive differentiation has been done here, and that is thrice. So this is a third order equation, third order differential equation. And what is degree then? Degree is the degree or power of that term which happens to be the order of the differential equation. Since this is a third order differential equation, and this term contains that order, and the power of this term is 1, so this will be a first degree but third order. So we can call it third order first degree equation, differential equation. So now we have already studied about degree and order of a differential equation. And what kind of difficult problems that arise in this section? Sometimes you will be given problems like this. Then when there is a square root or a cube root, directly we cannot find the degree and order. So we have to find an LCM of these two. This is third root and this is the second root. So 2 and 3 make 6. LCM of 2 and 3 is 6. So have a sixth power of both the sides. Now root over d square y by dx square whole to the power 6 is equal to 3 d cube y by dx cube whole to the power 6. That means we have made sixth power on both the sides. Now since this is 6 and this is 1 by 2, the power is 1 by 2, so this will be whole cube d square y by dx square whole cube is equal to 3 to the power 6 into, this is sixth power and this is 1 by 3 because it is third root, so 6 upon 3 is 2, so this will be d cube y by dx cube whole square. So we have an equation like this: d square y by dx square whole cube minus 3 to the power 6 d cube y by dx cube whole square is equal to 0. Clearly this term contains the maximum number of successive differentiations, so this is the term containing the order, and this is third order, and the degree of this term is 2, so this will be a second degree but third order equation, differential equation. This ends this section, differential equation, their degree and order. Then we go for formation of a differential equation. How to form a differential equation? We know that differential equations must involve differentials in x, y, z or something like that. Any variable, differential of any variable should be a term in a differential equation. So if we are given with equations like this, y is equal to a e to the power x plus b e to the power minus x, only this equation is given. This is a general equation. There are exponential terms, so it may be a combination, a hybrid function of algebraic and exponential functions. So how to form a differential equation from this? Let us first find out the first derivative, which is dy upon dx, means d by dx of a e to the power x plus d by dx of b e to the power minus x. I think by the time you reach differential equations, you must be very much thorough about the differentiations, and you should directly write the differentials here. So here constant a, e to the power derivative of e to the power x is e to the power x, and here the constant is b, e to the power minus x should also be e to the power minus x, but differentiation of minus x yields minus 1, so here minus 1. So we get y1 is equal to this much. This is the, if this is the equation 1, then this becomes equation 2. Now we see that these terms are equal, but these terms have changed their sign. So let us go for the next differentiation. Go for the second derivative. That means it will be dy1 by dx, which will be d by dx of a e to the power x minus d by dx of b e to the power minus x. So this will be here a e to the x as a derivative e to the x, this is minus here, and b e to the power minus x, and another minus sign yielded here, so it makes plus. So y2 becomes a e to the power x plus b e to the power minus x, equation 3. Now try to see if there is a link between these three equations. Second and third have the same difference as first and second, but look at first and third, the RHS part is almost equal. So we can infer from these two that y is equal to y2. From equations 1 and 3 we have y is equal to y2. That means y minus y2 is equal to 0. This is the difference. This is the equation answer. So form a differential equation using this is the method, and in this method we are successively differentiating the functions to reach our target. And are all formations done in the same way? Formation of a differential equation can also be done by elimination method. If we take this first derivative, we had already got a e to the power x minus b e to the power minus x. This was equation 2. What if we add these two? We get y plus y1 is equal to 2a e to the power x. And what if we subtract them? We get y minus y1 is equal to 2b e to the power minus x. So we have a and b, which are different things. So from this we get e to the power x is equal to y plus y1 by 2a, and from this we get e to the power minus x is equal to y minus y1 by 2a. So if we put these two values here, we can also find different equations where y1 and y1 will be there. So if these things, if we eliminate a and find b, if we eliminate a and b from these equations and get some equations, then also this is a differential equation. Now if we put these two values here, we can find y is equal to here you can write a e to the power x is equal to y plus y1 by 2, and b e to the power minus x is equal to y minus y1 by 2. So this term is in terms of y and y1, this term is also in terms of y minus y1. So here by putting these values we get y plus y1 by 2 plus y minus y1 by 2. This can also be called a differential equation, but this is not the proper way to find a differential equation. The real way is to go through multiple differentiations so that the first and the last equations resemble, which we just did earlier. Next, let us go for solution of a differential equation. Differential equations which are difficult to solve generally are intermixed. They are in the hybrid form. Both the sides of the differential equations do not contain differentials of the same variable. Look at the problem like this: x dy minus y dx is equal to 0. We cannot separate dy and dx here, so let us go for x dy is equal to y dx. Now if we separate the variables, means we take the y to one side and x to the other side, then we can write this as dy upon y is equal to dx upon x. Now it is easy to integrate both the sides. We have integration of dy by y is equal to integration of dx plus dx by x. That means ln y is equal to ln x plus, we can write ln c, so that we have ln y is equal to ln cx. That means just if we put ln away, then we can find y is equal to, if you take anti-logarithm, then you get y is equal to cx. This is the solution. This method is known as separation of variable method. Separation of variables. In this process, what you do, you put the two variables to each side, see y on one side and x on the other side, and then integrate both the sides to get them. Then the next higher form will be an equation of this form: d square y by dx square is equal to 3x plus 2. In this we have a second derivative here, so let us put dy by dx is equal to h or p, suppose p, another variable. Now this on simplification will be d by dx of dy by dx is equal to 3x plus 2. Now since this is p, this will be dp by dx is equal to 3x plus 2. That means dp will be, multiply them so that the variables are separated. Now integrate both the sides. Integration of dp is equal to integration of 3x dx plus integration of 2 dx. That means p is equal to, this is 3 into x square by 2 plus 2 into x plus c. That means we get p is equal to 3x square by 2 plus 2x plus c. Since this is the first time we are differentiating, so let us take it c1 here. Now p was the alternative, the substitute for dy by dx, so we can write it here again: dy by dx is 3x square by 2 plus 2x plus c1. Now separate the variables, keep dy on the left side and take dx to the other side. You get 3 by 2 x square dx plus 2 x dx plus c1 dx. Now integrate both the sides. Integrating dy will be 3 by 2 integration of x square dx plus 2 integration of x dx plus c1 integration of dx. That means we get y is equal to 3 by 2 into, this will be x cube by 3 plus 2 into x square by 2 plus c1x and a constant c2. If we simplify, we get y is equal to 3 cancels here, 2 cancels here, so you get half x cube plus x square plus c1x plus c2. This is the solution. So in this case we have used all the methods for solution of a differential equation where we have only to separate the variables. So when there are the equations of the type x dy is equal to y dx, where we can separate simply, or dy by dx is equal to 3x plus 2, in which you can separate them like dy is equal to 3x plus 2 dx, and integrate both the sides to get y is equal to solution. So we have two different ways to solve them, and this completes the part 1 of differential equation. In the next class we shall go for linear differential equation, and there we shall use integrating factor, multiplication of integration factor on both the sides to solve them. So till the next class we end the chapter here, and if you like this video, please comment, share and subscribe my channel Subhasir'sclasses. Thank you. Bye.